we are going to see a problem on square pyramid, and for that here we have a question. A square pyramid, side of base 40 mm, axis length 60 mm, has one of its side of base in VP. The axis of the solid is inclined to VP and HP at an angle of 30 degree and 45 degree respectively. Draw its projections. So this is the question in front of us. Just by reading the question, it was understood that the type of solid is a square pyramid. So first, I'll draw the diagram of a square pyramid and explain the initial conditions. So here is a square pyramid. It is called a square pyramid because the base is in the form of a square, and here it is having four triangular faces, and these are the slant edges of the pyramid. O is the apex of this pyramid. Now, the condition is mentioned that square pyramid, side of base 40 mm, axis length 60 mm, has one of its side of base in VP. So there are two ways in which the square can be drawn. This is the first way in which the square can be drawn. That is, here the square is resting on its corner. I'll give it as corner A. So it is resting on this corner. Next, there is another way of drawing a square. Now in the second case, this square pyramid is resting on its side of base, or we can say edge. In the first case, it is resting on this corner, which is corner A. In the second case, it is resting on this side, or called as edge. Now if in the question, if we see, it has one of its side of base in VP. So if the side is in VP, it means out of the two conditions, the second condition is correct. We have to take this condition. And since it is in VP, vertical plane, then this square will be visible in the front view, that is in VP. So we have to draw the initial condition, drawing the square pyramid, that is its square in the front view, and then projecting it into the top view. So with this, let us start with the solution to this problem. Since the square pyramid is resting in VP, the square will be seen in the front view. So I will be drawing the square here. Next, I'll give the notations to it. 1 dash, 2 dash, 3 dash, and 4 dash. Here is the apex. Now this apex will look like a point in case of the front view, or we can say the apex or the axis of the pyramid will appear as a point. Next, projecting it into the top view, that is drawing the top view of this square pyramid which is resting in VP. Axis height is given as 60 mm. Point O of the apex. Now, since this is the initial condition, here I'll be making it dark. Now I'll make the edges dark. Now, after the initial condition has been completed, it is given that the axis of the solid, that is the square pyramid, is inclined to VP and HP at an angle of 30 degree and 45 degree respectively. So inclination with VP is 30 degree and that is denoted by phi. Inclination with VP is denoted with phi and that is 30 degree. Inclination with HP is denoted with theta and that is equal to 45 degree. Now, the inclination of the axis is given in the problem. That indicates the true shape of the axis. It means whatever inclination is provided, that is for the true length of the axis, which is 60 mm. Now if I see here in the initial condition, this axis height is 60 and here I am getting it in the top view. So if I make this axis inclined, this inclination is seen in HP. So it means if the inclination is seen in HP, it is with respect to VP. So the inclination, if we see with respect to VP, it is given as 30 degree. So in next case, I'll have to make the axis inclined at 30 degree. That will be the inclination with VP seen in HP. Now, if the axis is inclined at 30 degree, it means the base is inclined at 60 degree because axis and base, they are perpendicular to each other. So if the inclination of axis is given, the inclination of base will be 90 minus the inclination which is there, that is 30. So inclination of base is 60. So here I am taking an angle of 60 degree. So that indicates the inclination of the base. In next case, the pyramid is tilted about point 3 and 4. So here the point which I am taking, that is 3 and 4, which is looking like a point in case of top view, but in front view actually this 3 4 is an edge. So here I take the distance of the base because I have made base inclined at 60 degree, taking the distance up to the axis. So here, since I have made the base inclined at 60 degree, angle between the base and axis, this indicates the axis, is 90. So this remaining angle is 90 minus 60, that is 30 degree inclination of the axis. Next, after that, I'll measure the axis height and plot it here. So drawing the inclined pyramid light and then I'll make it dark. Now after drawing this inclined pyramid in the top view, that is I have made the axis inclined at 30 degree. Now I'll project the points and draw the front view for this. And for drawing the front view, observer is located here. Those points needs to be projected first which are closer to the observer. So if I see from here, apex is closer. So apex will be projected with a light line. Next, projecting the apex from the front view, that is point O dash. So intersection of point O from the top view, O dash from the front view gives me point O dash in the front view. Next, closer to the observer, there is again point 1 and 2. This is actually an edge, but here it is seen as a point in the top view. That also needs to be projected. So point 1 is here, that is 1 dash. Here is 1 dash and this is 2 dash. Next for points 3 and 4. So now, in a similar manner, at projected points 3 and 4. Here 3 and 4 they are onto the same line. So 3 dash where it intersects, that is 3 dash, and here 4 dash. Now how to join these points? Whenever we are drawing, the outlines are never hidden. So outlines will be solid. So first I'll draw the outlines light from O dash to 4 dash and O dash to 3 dash. Now the outlines I have drawn. When the observer is here, that is, he is looking into the top view and trying to draw the front view, then these points 1 and 2, it means that is an edge. That edge is closer to the observer, whereas the edge 3 and 4 is not visible to the observer because it is coming behind the observer. So 3 and 4 will be hidden. So when I am going to draw this, edge 1 dash 2 dash will be dark, 2 dash 3 dash, that will also be dark. Then 3 dash to O dash, 1 dash to 4 dash, 4 dash to O dash. Now this much portion of the pyramid is visible, whereas edge 3 and 4 that will be hidden going behind the observer. I'll project the axis as well. Now once I have drawn the axis, I can say that in the top view we are getting the true length of the axis, which is 60, but here if I see in the front view, this is the apparent length of the axis, and it is also called as EL, that is elevation length. So I'll write the notation here that this apex in the front view, which is apparent length, that is called as elevation length because it is seen in the front view, and that too the shape is not true. True shape is, true length is 60 mm, but here the length changes when I am looking it as an observer and drawing the front view. So in the next case, the first angle of the axis, it was given as 30 degree, and now the angle will be changed. Angle with respect to HP, that is 45 degree, it will be seen in VP. Now the inclination 45 degree is given for the true length of the axis. So first I'll draw a line inclined at 45 degree. It means if the axis is inclined at 45 degree, then the base is also inclined at 45. 45-degree line. Now over this line, I'll draw the base, which is, I'm going to copy this entire pyramid which is there in the front view, inclined at 45 degree. That is, the base is inclined at 45 since axis is also at 45. This is 1 dash, and here there is 2 dash. Now I'll mark the axis over it exactly at half. From here I am going to draw a 90-degree line inclined to the base. It is perpendicular line. Now here I have drawn this light line which indicates the axis. Here I have taken 45 degree for the base. This angle is 90 between axis and base. So the inclination of axis with respect to xy line, this will be 45 degree. But here this 45 degree is for the true length of the axis. This length is not the true length, which is EL. So over this line 45 degree, I am not going to plot EL, but I am going to take the true length. This procedure needs to be followed here. So the true length of the axis, either I can take it from the first diagram or I can take it from the second diagram. The true length will remain same because here also it is 60 mm. In the second case also 60. So if from that I am going to cut it over here. Now from this point, which is the apex point, I'll say O dash. From that I'm going to draw a light horizontal line. Now projecting this light horizontal line. Next, after this I am going to take this EL, that is the apparent length of the axis, and then I am going to mark this apparent length over this light line which I have drawn. It is cutting here. So means this point O dash will shift to the new location when the true length is changing, that is now it has become apparent length. So even the inclination has changed. Next, it means the axis is passing from this direction. Then I'll draw this pyramid light and then I'll make it dark. After that, here there is also edge 1 to 4. So for that, from 1 I'll draw a perpendicular, and I'm going to mark over it a distance equal to 1 dash 4 dash. Now here I have marked point 4 dash. I'll say it is 4 double dash. I'll give all the notations here as double dash. Next, at the same distance there is point 3 also. So in a similar manner, parallel to this 1 to 4, I am drawing a line from point 2. Then from point 4 I will be projecting it. So this point, which is 4 double dash, I'll take it here. So that gives me point 3 double dash, joining it to O double dash. Next, I'll make this inclined pyramid dark. 3 double dash to 4 double dash is a hidden line, which is a dotted line. 1 double dash to 2 double dash. 2 double dash to 3 double dash. Next, here 4 is connected to O, even 3 is connected to O. So I'll connect them to point O dash, O double dash, which is the new apex. Now, here is this inclined pyramid where the true inclination of the axis was given, but if we see in the front view, we are getting the apparent length of the axis. So that apparent inclination also we have found out. It means now the axis, which is the apparent length of the axis, is inclined at some other angle, and it is not at 45 degree, because at 45 degree there would have been the true length of the axis. So after projecting or getting this solid pyramid, next I'll draw its top view, and for that the observer is here. Now those points needs to be projected first which are closer to the observer. So if I see from top, apex is closer, that is O double dash. So O double dash here and point O from the top view. Wherever they intersect, Here we get the apex, that is point O. Next, point 1 double dash will be projected, and from here point 1 will be projected. Next, on the same line there will be point 2 as well. So 2 double dash, taking it from the front view. So here is point 2. Next, point 3 is on XY line. So here is, I'll take the projection of point 3 double dash. So this is point 3. Next, point 4 is on XY line again. So projecting 4 double dash, which gives me point 4 here. Now how to connect these points? The outline of the drawing is never hidden or dotted. So first I'll draw the outline, that is connecting 4 to 1. Next, 1 to the apex O. Then apex to point 3. Now, if the observer is looking from the top, then this edge 1 to 4 will be visible, and along with that, here we can say that even the other edges, like for example, if we see in this front view, that is the second condition. Here also, since the pyramid is a complete solid, so we need to connect it from O dash to 1 dash, and even from O dash to 2 dash, means that is visible. So first drawing it light and then I'll make it dark. Next, the same edges from O double dash to 2 double dash will be dark, and O double dash to 1 double dash will also be dark. Now when we are looking from top, in that case this edge 4 to 1 will be dark. At the same time, this triangular face O double dash, 4 double dash, 1 double dash is visible to the observer, so that will also be made dark. So this triangle is visible. Next, this edge 2 to 3 is going behind the observer, so edge 2 to 3 will be hidden. It is hidden. Next, after this, 3 to O, that will be dark because it is the outline. So now, after projecting this pyramid, now getting the edge 3 to O, next, this edge which is O to 2, that will also not be visible to the observer, so that will be hidden. It means this face, triangular face 0, 2, 3, which is O double dash, 2 double dash, 3 double dash, is going behind the observer, so that face is not visible. Next, edge 1 to 2. For that, here the triangular face is O double dash, 1 double dash, 2 double dash. That triangular face is also going behind the observer, so again that will be hidden. It means out of the 4 triangular faces, only 2 triangular faces are visible. Next, after completing this, I'll give the dimensioning to it. The edge of the base is 40 mm, axis height is 60 mm given, and the angles I have marked for the axis. And with this, we complete the problem.